Hello and welcome back. This is the second video in this wood lathe restoration. In the last video I made this stand for it. So if you haven't seen that, I'll leave a link in the description so you can watch that video. In this video I want to work on the CVT or Reeves drive. Technically I'm not sure what the difference is, but in these videos I'll refer to them as the CTV or Reeves drive, and it means the same thing. I mentioned in my last video that I hadn't made the mounts for the motor here yet, and that's because I wasn't sure where the motor was going to go vertically. Working out the pulley sizes and distances between pulleys is quite complex, and I thought that the best place to start would probably be the end result, which is the speed range that I want for this lathe. I went online and I looked up the specifications for 21 lathes, and I looked at the range of speeds that they all do and make a note of them. Some of these lathes are fully electric, so they have electric speed control. Some of them have belts with fixed pulley sizes, so you change the belt. Some of them have adjustable speeds with belts, so similar to what I'm building here, a Reeves drive or CVT. And some of them have a mixture of both belts and electric. But anyway, I ran an average of the speed range and it worked out very close to what I'd worked out with the pulleys. And I'll bring up a spreadsheet a little bit later on and explain how I worked out what size pulleys to use. On this lathe here, this is what I'm going to do with the pulleys. The belts that I'm going to use are from a variable transmission scooter. So they're designed for this type of application anyway. But the problem is they're 20 millimeters wide, which is wider than the stock standard pulley that's on the spindle here. So I'm going to have to make up a new pulley for the spindle anyway. And that pulley is going to be a 100 millimeter or 4-inch pulley. The pulley down here for the motor is going to be a 3-inch or 75 millimeter pulley. And again, I'm going to have to make that one up myself because this pulley on this motor is narrow as well, so it's not wide enough. And of course, there will be a CVT pulley in the middle here. And that pulley there is going to have a range of 2 inches or 50 millimeters to 6 inches or 150 millimeters. So this is around about 150 millimeters here. So that'll be in the middle. Be one belt around there, one belt around there, and this will be controlled in the front of the lathe to change the speeds. Now I'm quite new to all these pulley systems and Reeves drives and CVTs, so I had to go and do a lot of research, and I learned quite a few things, and I wanted to share those with you and how I sort of came up with the pulley sizes that I needed to put on the lathe. Now look, if you're not interested in that part of it and you just want to see the build part, then you can skip ahead on the video. So here on the right we have pretty much what you see on the lathe. We have the lathe pulley at the top, the CVT will be in the middle, and the motor pulley will be down the bottom. So I call this the primary drive. So the motor's turning the CVT, and then the CVT turns the lathe pulley, and that's what I call a secondary drive. So the primary drive is in this box here, and it talks about the 3-inch pulley, which is the motor pulley, and the 2-inch CVT. So when we're going from the motor pulley to the small part of the CVT when it's in that mode. And that gives us how many revolutions we get. Just remember, this is a motor, so we have a constant here which is 1420 RPM. So the motor is going to do that all the time. It doesn't matter what pulleys it's going through, and it's the end result that we're interested in. So that gives us 2130. That's the highest speed we would get out of our CVT pulley. And if the pulley was in the other mode, where it was the belt was riding around the outer sort of circumference, then we'd get 710. So that's the first stage, the primary drive. And then we move on to the second stage, and the numbers that we get from the primary side are put down in here, and then we do the calculation with these two pulleys. So basically, if we're starting off with 2130 RPM and we're in the 6-inch mode, so we're going around the outside of the CVT, and then we're going around our 4-inch pulley here at the top of the lathe, then we're going to end up with 3195 RPM. And I did this for, so this sort of in pairs. So the setup number 1 shows you when you are running this with the CVT in the lowest mode and in the highest mode. So that's why there's 2 entries for each. So I experimented around with different pulleys on the motor, so 3-inch, 2-inch, 4-inch, and different pulleys on the spindle of the lathe as well, 4-inch and 5-inch there. And as I mentioned, I did 21 lathe reviews. Well, I looked at the specs of 21 lathes, and the average speeds were between 364 RPM to 3,251. And that's what this range is here for this setup number 1. So a 3-inch pulley on the motor. We're going to use a 2-inch to 6-inch CVT range. And then, of course, we're going to use the 4-inch pulley on the spindle of the lathe. And that gives us that range, which is very, very close to what the average was anyway. Some of those lathes, they can turn them right down. The electronic ones, they can turn down to 40 RPM or 60 RPM. There's not a lot that do that. And I'm just wondering how often you would need to do it. And do you muck around and spend the time and effort in doing that for something that you might not use that often? So I think I'm just going to stay with the average, and we'll use these pulleys that I have in setup number 1. And I think that will work fine. It's been almost a couple of weeks since that last footage that I shot for this video. The company that sells these belts, they were sort of closed well into the new year, so I didn't want to go ahead and start making up these pulleys without getting the belts first. So now that I have the belts, we can carry on and get these pulleys made. So the lathe pulley, or the original one that came on here, is a stepped pulley. We'll just be making like a single groove pulley to replace this one, and same for the motor down the bottom there. Now I don't have any aluminium big enough for this, so I'm going to have to cast some, and I was going to cast it in sand, which I haven't done before, so this is going to be kind of a new experience for me, casting these pulleys in sand. And I have reached out to Mark Presling, as I've seen on some of his videos. He's done quite a bit of sand casting, so he's provided me with a bit of advice, so thank you very much for that, Mark. The first thing I need to make here is a flask, which is used for sand casting. And I'm really new to this, so all of you sand casting gurus, you can stop laughing now at my design here. But the important thing here is that the 2 halves of the flask fit together without any play, and that's what I've achieved here, so I think this will work. The next step is to make the patterns. So this is the 2 pulleys, the one for the motor and the one for the lathe spindle. And I'm just using a bit of offcut of wood here, scribing a circle. And then I drill out a 16mm hole in those 2 pieces. I just use a saw to roughly cut off the edges. Ironically, it would be really good to have a wood lathe to turn these wooden pieces. Let's turn down the outside here. And I'll tell you what, this is pretty messy. And then we do the same for the larger pulley. Now I need to make a 40mm shaft that goes into these pulleys. I'm just using a bit of square timber there and turning it into a nice round cylinder. Then I put those pulley blanks into the 4-jaw chuck, and I did dial it in. It's a bit weird doing it on wood. Then I check out the fit, and that fits good. And then we're off to the bench to glue the pieces together. And I use the same round piece to fit the other pulley on the other end. Now I go back to the lathe and I put them in. I'll just do a final true up here. And I take down the length of the pulley to the right dimension. And then those pulleys will sit in the flask like that. The next step is to make up the green sand, and that's made up of this standard play sand that you get from Bunnings and some Butanite clay. Now this stuff is wet in the bag, so I have to put it on this board and rake it out so that it can dry out in the sun and the wind. And then once that's dried out, I start filtering it out. This is a 2mm sieve, and I actually do have a 1mm sieve as well, so I may use that to get even finer sand. So next we work on the bentonite, and this is just cat litter, so it's bentonite clay, and it comes out with these sort of granules. So they have to be put into the machine and ground up into pretty much like dust. And then that's put through the sieve, and also put it through the 1mm sieve. Anything left over goes back into the machine and run through again. I basically grind up the whole bag, so I have plenty of bentonite clay for future use. Now it's time to mix it in, so I'll put about half of it into the bucket of sand, sort of scoop it around a little bit there, and then I get onto the drill with a paddle and sort of just mix it in. And put the rest of it in, and they get mixed up again. And then I start to add the water. First do it by hand and then use the drill again to mix it up. I was using 2 buckets here, so I was tipping it from one bucket to the other and back again, and using the drill to mix it up. So just to make sure that anything in the bottom of those buckets were getting mixed up properly as well. I tested it out, squeezed a handful there, and it broke into 2, so that looks pretty good. Now we work on the mould, and I always like to make things harder than I need to, so these patterns are too high for this flask, so I have to move the parting line. And I'll put those in there, put a little bit of powder on them. And then we're using a bit of facing sand, so it's the same sand, just sieved. And then we put more sand on top and that gets compacted down. And then we strike that off. And that's the drag side of it done. Now I didn't really know what to do here, whether to turn the whole lot over or just take the drag off and tip it over by itself, but I tried to turn the whole thing and the bars fell out, but that was all fine anyway. There's a few broken bits there, but they're on the edges, what needs to be struck off anyway. So everything is looking pretty good so far. and then we start working on the coat. Any of you experienced sandcasters out there will know straight away that I've made a couple of mistakes here. I get to around about here and I realise what I've done. Yep, I forgot to put a riser in and I forgot to put a sprue in, so there was no way to pour the molten aluminium into the mould. So take two. We pack it all down. We remove the riser and remove the sprue, and we strike that off. And I forgot to cut a basin in here while I had it in this configuration as well, so I have to come back and do that again later. I'm not really sure if this is the right thing. I'd cut the runner and the gate in the cope instead of in the drag where the patterns are on the left there. So anyway, I've put it back together and I'm cutting the basin in here now. And I'm just making a little ridge there so that when you pour the molten aluminium in, it will pour over that little ridge. Now I'm removing the patterns. These patterns had no draft on them, so there's another mistake, and it's sort of chipped away on the side there again. Remember, this is my very first sand casting, so very new at this. Anyway, I try to fix up what I can. And we're at the stage where we put it all together, ready for casting. Got a couple of screws there that I lock that down with. I forgot to turn on the video camera when I was pouring, but I think this went okay. I poured it in and it took a lot of metal. They are big parts, so that was expected. And the riser filled right to the top, so I was happy with that. Here's the moment of truth. And initially they looked not too bad. Well, there it is. That's the casting. Maybe a few more craters on here than what are on the moon. I've had a bit of a look around and it's probably okay and machinable, I think. I did make these larger than the size so I could machine them down. And I think the only question I have is once it's machined down, you know, is there any porosity in there? So I guess the next step here then is to just cut off the sprue and the riser and put them in the lathe and start machining them. The casting does not have any machined reference surfaces, and the stub that's in the chuck now, I want to use that as a reference surface, but I first have to machine it, and to do that I need to put this in the four-jaw chuck, so I'm machining these outer surfaces on the big diameters first. Now we've got that in the four-jaw chuck, I'm machining the little stub, and this will be machined to size. And from that point I will put this stub in the four-jaw chuck and dial it in, and then I'll do all the machining for the whole pulley. Now it's turned around in the four-jaw chuck and I'm just tidying up the face and the surface. And then we start to cut the groove. Now I'm using what looks like an oversized parting tool here, and this is used to cut down to the depth that we need and the width that we need for the bottom of the groove. And then I cut the right hand and left hand tapers. These are 15 degrees. And the next step is to drill and bore out the centre hole to 25mm, which is the spindle shaft size. Just to make it look like a pulley, I've left the compound slide at 15 degrees and I'm just putting a little bit of a taper in there. That's the spindle pulley completed. I've made this bit extra long here, so I'm not really sure how far out we need to come at this point. So I can chop this off later on and bring this in closer. Now the casting, as I mentioned before, had a lot of holes in it. You can still see some there. There's a bit of porosity in there. It wasn't a very good casting, to be honest, but I think it's pretty solid. I mean, the wall thickness here is 7mm each side, so that should be plenty strong enough, I think. Now I pulled the headstock apart and re-lubricated the bearings. The bearings seemed fine, they just needed to be lubricated so it spins nice and smooth now. But I did find one issue that I might have to address later, and that's under the faceplate here. So the threads here are pretty stripped out, and these are the threads which are on the spindle itself, so it's not a nut that fits on here or anything like that. So I'll probably have to address this maybe a little bit later on. This faceplate does fit on and it does kind of tighten up, so we'll see how we go with that to start with. But I think if I put anything heavier on there, like a chuck and stuff like that, I probably really need to make another spindle for this lathe. Off camera I'm going to go and do the other pulley for the motor. It's the same process, so no need to record that. And then we'll come back and talk about the Reeves drive. I have finished the smaller pulley that goes onto the motor down here, and I've just sort of propped it up with a 6-inch pulley in the middle. That's not the Reeves drive, that's just temporary, just to sort of illustrate how this is going to be. But I've actually run into a major problem. The problem is with these belts and also the pulleys now that they've been machined to the same profile as the belt. And the issue is the included angle for these belts is 30 degrees. The issue with that is that I don't actually get the range that I need in my CVT in the middle here with the 30-degree included angle. Let me take you over to the table and maybe it'll be a bit easier to understand what I've written down here. This is the center line, and these angled lines here represent each side of the pulley. So that angle in there and that angle in there. And we're basically only looking at this top piece here, so sort of one half of the pulley. Now these lines are at 15 degrees, and that's what that belt is on the side. So it's got a 15-degree angle on the belt. So when the belt is right down the bottom of the pulley, like this, that will be in the, if we're talking about the motor, it'll be in the slower speed. And then this side of the pulley would come in and the belt will be pushed up, and then it would come into the contact, well, the belt will be on the side here. So it'll be a little bit like that. But the issue is now down the bottom here, we are right up hard. The two pulleys are right up hard against each other. So it can't move in any further to cause this to move up any higher. So that gives us a distance of 27 millimeters from the top of this belt in this position to when it's moved up to the top of that belt in that position. And so if we add two of those together, because we're only looking at half of the pulley, then we get a range of only 54 millimeters, which is, you know, just over 2 inches. If you recall before, I wanted the CVT to have a range of 2 inches to 6 inches, so we're sort of only moving half the distance. Unfortunately, that is not going to work with these belts that I have. So this is the proposed solution, is to buy belts. You can get them with a included angle of 22 degrees. Probably something I should have done from the beginning in hindsight, or I should have really done all this working out way back then. The pulley plates are machined at 11 degrees on each side. This particular belt here will then be able to move right up that distance there. So that's, 48 millimeters. So it's almost 2 inches. And of course, we're looking at only half the pulley. So that'll give us almost 4 inches of travel, which is kind of where we started out to be in the planning. So I think that's going to work for us. The only issue is I have to, of course, source some belts. And doing a quick look around in New Zealand, I haven't found anything here. I found belts, you know, overseas, but they can take quite a while to get here. Now, while I'm in the process of redesigning the pulleys and getting new belts and that type of thing, I was going to take that opportunity to do a bit of a design change as well. So initially, I didn't want to have a big pulley up here on the spindle taking up a lot of room. So that's why I came up with this design. So I've seen this design on old lathes, and they have the CVT in the middle and the two belts, and they move this up and down, and that sort of changes the ratios and the speeds. That's going to still work. There wouldn't be any issues with that, although it probably is a little bit more complex than the other way they do it. And let me just remove that belt. The other way they do it is if you have your motor on here and it's just a single belt, and both of these pulleys are CVT pulleys. So you have two pulleys that move in and out sort of opposite to each other. So when this is opened out and the belt is right down low on the smallest part, this one opens out, closes up, and the belt runs along the outside like this. And vice versa, when you change the speed, you manually or using a lever change the belt on one, and the other belt will follow suit, and that gives you your speed range. So I was thinking of going back to how this lathe was when I bought it, where it had the motor out the back here. So basically that would be out the side there like that. The motor will be mounted at the back, and I'll try and get a longer belt so that it's a little bit lower, and then we'll have a control in the front here that we can adjust this pulley to change the width of it. And of course this one here is spring loaded, and that just follows whatever this pulley here does. So I think that's what the plan's going to be. I'm going to have to order a belt, and I'm not sure how long that's going to take to come. So the next video might be a little while. I do have a whole bunch of other projects that I can carry on with, so there'll be other videos as well. But it's just a little bit of a pain that, you know, I have to wait for belts to turn up and things like that. So in summary, a little bit disappointing that these belts will not work and the pulleys that I made will not work with this project, but it's not at a loss. I can still use those pulleys and belts in other projects. If you do like my videos, click on the subscribe button and click on the bell if you want to be notified when I release new videos. I hope everyone has a great day, and thanks for watching.